Hello there. Now we are going to be trying to learn what is the principle of virtual work. As you know, as a mechanical engineers, we know that the work is the product of the applied force into the displacement of that particular body. So on this basis, that is going to be comes to the mechanical work. So by using this mechanical working principle and how we are going to be developing the principle of virtual work, today's we are going to be seeing. And before going to that, we are going to be discussing about what is the work of a force. As you know, that force, the definition is nothing but it's trying to change the position of a particle, or it's trying to keep that body in the same position. If the force is not going to be applying, the condition of that body or the particle is going to be remaining in that position itself. If the body is in the motion, continuously is in the motion itself. If the body is in the rest condition, that is in the completely in the rest condition. So then work is going to be, because this work is going to be happening because of this force. As you know, the work is going to be, definition itself is going to be the force into the displacement we are going to be calling. So here I am trying to explain by taking the one of the particle P over here. So I have taken on a plane the particle P. So what I am going to do, if a particle P is going to be subjected to a force, so I am going to be made to subjected to the force, which is and the particle is displaced by an infinitesimal displacement, the ds. Okay, so then I am going to be taking this the statement, I am going to be converting into the pictorial view. So here, so there is going to be, in this case, the particle is going to be subjected to the force. I am going to be taking the force not in the horizontal direction, not in the vertical direction, rather than I am going to be taking the inclined position. So that is going to be your, the F is going to be your magnitude, and with the horizontal, it is going to be making an angle theta. This is going to be your line of action. Right? So then in this case, what will happen? So the force F is going to be acting in this case. So then after the certain duration of the time, or the force is going to be acting on this particle, so then it will going to be change its position from point P to the P dash. So that I am going to be taking over here. This is going to be the P dash I am going to be calling. There we can see the particle is going to be subjected to the force inclination of the theta. The same, the particle is not moving in the direction of the force, but rather than it is moving in the horizontal direction. So what it means that we had applied some constraints, we need to assume we had applied certain constraints so that the particle is going to be moving in the horizontal plane. So that the distance from P to P dash I am going to say that ds. So what is the F is going to be? F is going to be your applied force, and ds is going to be your infinitesimal displacement we are going to be calling. So then what is the work done? So as we know, the work done is nothing but the force into the displacement I am going to be saying. But in this case, the force is not acting in the horizontal direction, not acting in the vertical direction, rather than it is moving in the inclined position. So what I am going to do, I am going to be resolving the forces into two components. One is the horizontal direction and one is going to be your vertical component. As you know, when I am resolving the force into horizontal direction, I am going to be getting, this is the adjacent component, where the force component is going to be your FH, I am going to be say F cos theta I am going to be getting. Similarly, the vertical component also I am going to be getting in this direction. So FV I am going to be say that is the forces of the vertical component, F sin theta. Can you see? These are the two forces, the two resolution of the forces we got it. So as we know that which force is going to be acting to move the body in the horizontal direction, that's going to be, we need to understand here. So can you see, this is the horizontal force is going to be acting along the particle, that means in the direction of the P dash, right? Due to this reason, the particle is displaced from P to P dash. This is going to be, the force is going to be acting, that's why it is displaced. And another force is going to be the vertical direction force is there. That force is going to be acting normally to the displacement of the system. So it is moving in the upward direction. So this force is going to be not participating in our work. That means the particle moving from P to P dash. So then what is your work done? So that work done is equal to F cos theta. This is the contribution of the force in the horizontal direction, and the ds is going to be your infinitesimal displacement. So from this one, we are going to be applying the, here in this case, the theta is going to be 0, theta is going to be 90 degrees. Then what will happen to that system? As you know, the work done is going to be the scalar quantity. What is the scalar quantity here? It is going to have the magnitude, but it have no direction. So that's why we are going to be considering the work done is going to be the scalar quantity. Now we will see, we are applying the theta is equal to 0, theta is equal to 90 degrees, then what will happen? Now see, this is going to be called, we are going to be called the mechanical work done. So for this, the work done is equal to f cos theta ds, that I am going to be substituting theta is equal to 0. So when I am going to be substituting in this equation f cos theta, so theta is equal to 0, the work done by the force f cos, I am going to be substituting theta is equal to 0 into ds is going to be your infinitesimal displacement we are going to become. Then finally cos 0 is equal to 1. Then the work done by the force on the particle, that is equal to f into ds. Is it clear? It means that the theta is going to be 0. It means that force is going to be always acting in the direction of the displacement of the particle. So then we are going to be getting, this is kind of the equation. If theta is equal to be 90 degrees, so then what will happen? Now I am substituting this theta is equal to 90 degrees in this equation. So that's the work done is equal to f into cos theta is going to be cos 90 degrees, that into ds is going to be your infinitesimal displacement. As you know, cos 90 degrees is equal to 0. So then this f into 0 is going to be 0, 0 into ds. Then the work done is equal to 0. So in this case what will happen, when the theta is equal to be 90 degrees means the particle, that means this force is going to be acting normally to the displacement of the system. When the force is going to be acting normally to the displacement direction or the constant direction, automatically the developing of that force, that means the displacement is not going to be happening with that vertical force, automatically the displacement also going to be 0 in this case. So the work done when the theta is going to be acting 90 degrees on the particle, it is going to be 0. So now we are going to be talking about the sign conventions. As you know, the particle is getting the displacement at the same time because of the force is going to be acting. So there we can see the work done by a force is positive. When the work done is going to be the positive, when the work done is equal to positive, when the work done is going to be the negative, this is going to be the statement we are going to be defining. Only the direction of the force and the direction of the displacement are the same, right? So the direction of the force and the direction of the displacement must be the same. Then only if the particle is going to be in these conditions, this is going to be the P. So then what will happen? One force is going to be acting on this particle is going to be the F. So the F force is going to be acting over here, and then the displacement is going to be taking place. So then this is going to be the ds is going to be your displacement, is the infinitesimal displacement. So then the force, the line of action, and the displacement, the line of action is going to be matching. Then the situation is going to be the positive. But some conditions where the load, the work done is going to be the negative. When the work done is going to be the negative, then the particle is going to be over here, but the force is going to be acting over here in the f direction, but the direction of this particle is going to be in the reverse direction. So that is going to be your P dash, I am going to be saying this is going to be your ds. So that means the applied force is going to be acting towards the right side, but the displacement of the system is going to be acting in the opposite direction. So then this condition we can say the negative, because the force is going to be the positive direction, but the displacement is in the negative side direction, because the work done is the product of the force and the displacement. Automatically plus into minus will become the minus of this scalar quantity of the work done. So this way we are going to be calculating the work of a force when it is going to be acting on a particle. Thank you.